Another big idea that functions in your work and has already come up with regard to the continuum is life and synthetic life. So, once upon a time when the world was simpler and vitalism was still an idea, we could cling to the hope that there really was some magical distinction between the dead and the living. But today, that distinction has been replaced with another continuum of, simple molecules on the one end and then creatures like us on the other. So this this continuum, I think, is probably going to be different from the intelligence continuum in crucial ways. Maybe I'm wrong, but how do you think of this one, and what qualities determine the ends of the spectrum?
Yeah, to be honest, I mean, clearly people do think about this, and if you, you could have Sarah Walker on, then she'll say some very interesting things about life. I don't think about it at all. I don't find it to be. I mean, it's weird because I'm in the biology department, but I don't find needing a definition for it. I don't find that particularly interesting. I spend all my time trying to figure out what the spectrum of cognition is. I spend pretty much zero time trying to figure out what kind of boundaries life might have. I'm not saying it's not a good thing to do. Like I said, there are people who do good work on this field, but and the reason I tend to ignore it is mostly because I don't think there's any one-to-one relationship between life and cognition. So I think that there are many things that have significant cognition that we wouldn't call alive, and vice versa. And I'm just much more interested in the cognitive spectrum. I don't know. I'm not sure what my research program would gain by trying to come up with a category of life.
Well, you already used the term synthetic life, though, and that comes up a lot in your papers that I've read. So how do you think of synthetic life? I mean, it just the modifier synthetic suggests that it's in contrast to something, at least.
Yeah. What I mean is, and we don't do the truly sort of minimal living systems when you're down to the molecules where it's really hard to say what you're looking at. We generally, you build things out of cells, out of existing cells. And so what's synthetic to me is the fact that what you've got as a large scale system is not something that came out of the evolutionary process on Earth. So something that was never here before, and that has certain interesting implications that you can derive by studying it that you can't get from natural systems that have had eons of selection pressures and all that kind of thing. There's something very special that happens when you can create and study a system that has never had those particular selection pressures. So that's what I mean by synthetic life. Is just something that's outside of the N of one example of the web of life that we have here on Earth.
And then just to further understand your thoughts on the definition of life, you mentioned Sarah Walker, for our listeners who don't know, she's an astrobiologist, I think. And if she were looking at another planet and there was something that clearly wasn't inert, like a rock, it was moving around doing certain things, we might ask, it's a natural question, is this thing alive? And that might have important, moral implications that I think you would probably recognize. But what I'm wondering is, you're just saying it's not really a crucial theoretical question for you. Is this thing alive? It's just more of a practical question.
I don't even know if if that will help you with significant moral questions. So this is just kind of a standard science fiction story from 150 years ago. You know, you're sitting at home one day and the spaceship lands on your front lawn, and this thing on wheels sort of trundles out, and it's kind of metallic and shiny. And it comes up to you and it hands you this poem that it wrote along the way about how happy it is to meet you and all that. So you're looking at this thing and you say, well, is it alive? I don't know, but does that what does that hang on, and does it determine your relationship with it, right? And so I think in the end, all of these thorny questions about how we ethically relate to other beings, I don't think they're going to come down to questions of, is it alive? And that's because I don't believe that evolution, and I don't believe that protoplasm and kind of the squishy stuff we see in living forms on Earth have any monopoly on creating morally important agents. I think those can arise out of anything, and in principle anyway. And so my relationship to that kind of being, my first question is not going to be, is it alive? I'm going to have lots of interesting questions about the cognitive level that it has, right? But I don't think I'm going to have any questions about whether it's alive. So, watching things move, Roombas move and they're not alive, and so on. So I'm just not sure of a lot of questions that get resolved by the life criterion as opposed to by the cognitive criterion.
Okay, and then there's a term or a framework, maybe is a better way of putting it, that I see in a lot of your papers, and what I have in mind is a multi-scale competency architecture. And I'm wondering if, just as we were talking about having good definitions is very important, is a multi-scale competency architecture a way of talking about this, a way of capturing something useful about what we mean by life?
I think that it's an interesting question as to whether life entails, whether it's possible to have life that is not using a multi-scale competency architecture.
Well, maybe you could explain what that is, since I didn't define it.
Yeah. Just very simply, what it means is that, we all know we are a multi-scale system structurally. That is, you've got this body. It may be part of some group or swarm, but within the body, you've got organs, they've got tissues, they've got cells inside of them, they've got molecular networks inside of them. And so structurally, we know we're this kind of like nested doll hierarchy of scale. But my claim is that beyond structurally nested, each one of those layers has also competencies in various spaces. So, for example, individual cells have all kinds of interesting behaviors in gene expression space, in physiological space, and metabolic space. And then you get to collectives of cells, meaning cells and tissues, and they have competencies in anatomical morphospace. So they navigate with a degree of intelligence. So there are certain clever things they can do. There are other things they can't do. And they navigate that morphospace. And then on top of that, you've got this individual that this at the scale of the whole body that has their own goals in three-dimensional space, and that's behavior and so on. And then maybe there are larger systems above that. So what comes along with this is the idea that you are made of parts with their own agendas and their own competencies, and that every higher level deforms the energy landscape for the systems within it or underneath it, right, for the subsystems, so that their competencies end up contributing to whatever the large scale goals are. And eventually those goals, and it's interesting, there's a lot of competition and cooperation. The large scale system can do all kinds of stuff that's really not good for its parts. But big picture, what you have is this like deformation of the option space for these cells. So their competencies end up being contributing to and being adaptive for the larger scale system. So that's the multi-scale competency. Life as we know it uses that extensively. Our engineering and robotics generally doesn't. We have swarm robotics, which is sort of climbing there, but.
Okay, so I was going to ask if you would propose that it's a general feature of living things that they're comprised of a multi-scale competency architecture, the complexity of which might scale with the cognitive light cone of the creature in question. But as you said, robots, which are presumably somewhere on that intelligent spectrum, don't exhibit the same sort of multi-scale competency architecture.
Yeah, I don't know. Well, it's an interesting empirical question as to whether a multi-scale competency architecture is required for high levels of intelligence. I tend to think it probably is, but certainly can't prove that. I think that it's more about so if I had to define life, here's what I would say. There are certain ways of arranging parts that do not scale their competencies. So individual particles I will claim, and we can talk about it if you want, but I will claim that individual particles are not zero on that spectrum. They are in fact on that spectrum incredibly minimally. They have certain nano competencies about doing very simple things. When you combine those particles into a giant rock, nothing has scaled up. That rock has basically exactly the same competencies as the parts have. And so that we don't call alive. There are other arrangements of things where you scale it in a way that where the system, where the competencies scale. You've moved into new problem spaces. You have a bigger cognitive light cone. You have these kinds of things have grown. Anything that scales like that, I think we call it life. That would be my weird definition of life, is that anything that really successfully scales the competencies of its components.